Hello people, so today we'll be solving LeetCode daily question 1438, that is longest continuous subarray with absolute difference less than or equal to limit. And in this we'll be in an array of integer nums and an integer limit, and we have to determine the size of the longest non-empty subarray such that the absolute difference between any two elements of the subarray is less than or equal to limit. For example, we are having nums as 8247 and the limit is 4. So my output comes out to be true 2, and I'll explain that. For example, if I am having the subarray 8 individually, it's a subarray itself, and the absolute difference is 8 minus 8, the maximum and the minimum number. So that is 0 between yeah. So which is less than or equal to 4, which comes out to be true. And then we are having 8 and 2 with maximum absolute difference of with the difference comes out to be 6, which is greater than 4, so it's not possible to form array. 8 to 4 is another sub array, but again the maximum absolute difference between any two elements, that would be obviously between the difference between the maximum element and minimum element. So that comes out to be 8 and 2 again, which is 6, so this is not possible again. Then we are having 8 to 4, and again we'll be picking up the 8 to sequence, so 6 is greater than 4. Then we are having 2 alone as a subarray. Yeah, then that's possible because 2 minus 2 is equal to 0, which is less than or equal to 4. So we can consider the length of this subarray. Okay, so the answer is 1 by now. Then we are having 2 and 4. The maximum absolute difference between here becomes the minimum, between the minimum and the maximum element becomes 2. Okay, and 2 is less than or equal to 4. So we can consider this as this subarray as valid one because we are having the length of the this length is 2, which has now increased, and we need to return the maximum length only. Return the longest non-empty subarray, so my output comes out to be 2. Then we are having 247 again, it will be 7 and 2, so the difference is 5. Then 4 alone, we have considered this case. 4 7 will again give me 3, which acha, sorry, my bad. But 4 and 7, yeah, the length is again 2, so this is again considered. Then we're having 7, so again this length is 1. So therefore the size of the longest subarray which is valid is 2. So that's why the answer comes out to be 2. So 2, that was a long explanation. So now let's quickly dive into the code. For this, we'll be using two DQs to keep a track of the increased, like increasing DQ and decreasing DQ, and then we'll be also having a sliding window. Okay, so let's have firstly a DQ of NTI. Use this instead. DQ of integer. Let's have increase. I'll change the name to decrease to array DQ. DQ. Oh, and here I'll change the name decrease. Okay. And now we'll be also having two pointers that are, first let's have answer equal to 0, my left pointer equal to 0, and my right pointer also equal to 0. Then what I'll be doing is that while right is less than the length of the nums dot length, what I'll be doing is I'll be fetching my num first, and num is equal to nums right. Okay, and then what I'll be doing is that while my not decreasing dq is empty, and my num is greater than last element of the dq. So decreasing dot peak last is the function, if I'm not wrong. P class, I'll keep polling of that particular element, decrease dot poll last. Okay, and similarly I'll be doing it for increasing as well. Okay, and now I just need to change the name where nothing is changed except for the while num is less than increasing. Okay, and then what I'll be doing is I'll be adding it to the increasing DQ. Okay, I guess, yeah, I should firstly add it to the decreasing as well. Decreasing DQ, let's say, dot add at the last. This is the number num, and then also in the increasing dot add last my current num. Okay. And then what I'll be doing is that while my DQ dot peak first minus, because as it's an increasing and decreasing DQ, and also we need the size of the, like the well, it's a very again we find with the elements which are just the minimum and the maximum, so we can keep a track easily. Minus increasing dot p first is greater than the limit, I need to keep popping off the element from the DQ. So then I'll be checking is that let's have left number that will equal to num left. Then I'll be checking if left num is equal to my the element at the first of decreasing in DQ, then I have to delete from there. Uh, Decreasing dot p first. I'll be decreasing it. I'll be removing it from there. So decreasing dot pole. Oh, sorry. Pole first. Yeah, pole first. Else it's obvious that it is from the increasing one. Increasing one. Increase dot pole first. Okay. And my left pointer will be incremented. Okay. And then while algorithms, I'll be getting my answer to be as maximum of my current answer minus the current length. Okay, that can be found by right minus left plus 1 and then the right plus 1. And at the end I'll be returning my answer. Okay, now let's give it a run. Okay, DE2. Oh, DEC. Another LIT. Okay, is there any error? No. Now let's give it a run again. Yeah, and it gets accepted. Now let's submit it. Okay, so null point reception. Okay, I'll have to see it again. I'll go through the code again. Why not? I will see that again and num is less than. Okay. Dot if left num is equal to this, else I have to do this. Oh, okay. So there might be a case. I'll just add another safety check here. If left num is equal to inc dot p first and c dot goal first. Okay, now let's give it a let's submit it again. Yeah, and it gets paid. Okay, so this was the thing. Thank you for watching.